Software Engineering Radio episode 49, Dynamic Languages for Statically Typed Minds. Welcome listeners, this is another episode of Software Engineering Radio. In this episode we are talking to Niklas Nielsen about dynamic languages for people who have a background in more static languages such as Java. We've recorded this episode at the Uppsala conference in, I think, end of October 2006 in Portland, Oregon. The quality of this recording is not that great. The reason is that I forgot to recharge the batteries of my recording device, so we had to record it directly on the notebook, and that meant that we only have one microphone, and that means that we have to pass around the microphone between interviewer and interviewee. That's why you can hear these microphone rumbles from time to time. Still, I think the quality is absolutely acceptable. And the content is interesting enough to not throw it away just because of the recording quality. So Niklas, welcome to the show.
Thank you very much.
And maybe we start by you introducing yourself a little bit, your background, and then we'll delve into the topic.
My name is Niklas. I'm consulting, doing education, coaching stuff on the west coast of Sweden. My background is from the beginning in embedded systems, doing a lot of automation, automotive stuff. Telematic stuff where telecom industry meets the vehicle industry. And since the west coast of Sweden is kind of like Detroit in Sweden, we have a lot of vehicle industry. So even though I tend to turn up on the server side more and more, it's still vehicle industry.
Okay, so let's look at the topic. If we talk about dynamic languages, what are some of the typical languages that come to your mind, and which one is going to be the language we're going to talk about mostly in this presentation or in this episode?
Dynamic language that I did some real work in was Python. Before that, I mean, still people, and including me, were doing a lot of JavaScript, which of course is a dynamic language, but turned out to be much harder since all the browsers did not follow standards very well. But in 2002, here at Uppsala actually, I had a really good experience attending Dave Thomas and Andy Hunt's Ruby in a Day tutorial. So we're probably going to talk most about Ruby today. And other languages that I think will be very interesting to follow is Groovy. Some people say that Groovy is dead before it's born, more or less. But I'm not sure. I mean, since it's a dynamic language backed by Sun, I think that may be a good thing.
Okay, then, just another remark how this episode ties in with some of the other episodes we already have and we will have. So we talked about Ruby in previous episodes, more on a general note, and this episode will focus on some of the programming language features that you'll typically find in dynamic languages such as Ruby. And then in a subsequent episode, we'll talk about domain-specific languages implemented in Ruby with using some of these features we're going to talk about today. So this ties in nicely into some of the other episodes we've already had and we will have. So some of the more interesting or advanced features. What are the key features there?
I think the first thing that you notice is the blocks, which is the possibility to pass around code to other methods. In Java, you can use anonymous inner classes and stuff to do things like that, but it's much more awkward, and the syntax really doesn't look as nice at all. The other things that really is different when coming from a Java perspective is that nothing is ever closed. You can open up a class anytime, you can mess around with it, you can add stuff, you can remove stuff. Things that people do in Java and have to do in Java by bytecode weaving, surgically going in, adding stuff, which BCEL, CGLib, and all these things are doing. It's not that people can't do it in Java, it's just that it's really, really hard. If you have a dynamic language, that's no problem. You just do it. It doesn't look any different than any normal code at all, and that's the main and largest difference to me. The meta-programming stuff, and that everything is always open. And that's what people think, from a static point of view, is really, really dangerous.
So maybe let's start with one feature, that is the typing itself. What is the difference between dynamic typing and static typing, and what is duck typing?
The first thing that you see is that you don't have to specify types, that you don't specify what type your references are, but that's just the surface. Let's say you have a number, 100 million or something like that, and that's a fixed num in Ruby, which is like an integer in Java. Let's say you multiply that by itself. In Java, that would just wrap, and there will be some really strange number that it's not correct. It will wrap several times, of course. But in Ruby, it will realize that, this is too large. Let's make this a larger type. Let's make this a big num. And something that I actually found out yesterday that I didn't think Ruby did, but it's something that we found out during the tutorial. That was, if you divide it again, it will actually turn it down to fixed num again.
So it's not just that you don't have to specify the type, it's also that an object can dynamically change its type at runtime.
Yes, exactly. And that's what it's doing. And that's if the environment realizes that this type is not longer sufficient, it will change.
And just to make this clear to our listeners, this is not the same as like polymorphism in Java. In Java, what you can, of course, do, you can have a reference that is typed statically to some class, and then you can polymorphically let it point to subclasses of that class. But you can never take a given object and change the dynamic type, its real class at runtime. You can always cast it, but that's just changing the reference type. It's not changing the object's nature itself.
Exactly. That's if you look at some of the classic object-oriented examples, when you have some object that you want to change role, stuff like that, that's really hard, because then you really have to change type, and that's harder in static languages.
So that means also that if you do this, then you probably, as we all know, you don't have any compiler checks whether types are compatible, and you probably also don't have a compiler check that checks whether, if you invoke a method on some object, whether the respective class has this method. And that opens some interesting possibilities with regards to the method not found, or what is it called in Ruby. So can you talk about this a little bit? And maybe, so what does some of the tricks you can do with that?
I think that's where people think is the largest drawback too. Because since it's really, really hard to figure out what a type is, it's really, really hard to figure out what methods are on the object you're currently working on for your tool, which means that the IntelliSense code completion stuff is gone. It's really, really hard to make a tool that helps that. That said, when you talk to an object, you don't talk about interfaces in the normal sense. You speak about, the question is not, are you of this type? The question is, can you respond to the messages I will send you, which equals to the methods I will call? Will you respond to those? Can you do anything with those? From the highest point, you can ask an object what messages it can respond to. But you usually don't, not too often at least. You just send the message. In a static language, you will start out by looking in the V table, and the caller will decide if the callee, the one who accepts the message, or should accept the message, if it can do it. So the caller, or rather the compiler, will make the choice. In a dynamic language, you will just send a message to the object, and you will see what happens. Usually it will answer, since you usually don't pass around the wrong objects. But it may be so that it doesn't have that method. Then the object itself it will get the message that, oh, here is a message, and you can't respond to it. So you will end up in a special method called method missing. Method missing takes a few arguments. One is the name of the method, and then it gets the arguments in the end, which makes it possible to parse the method name, which makes, for instance, the trick that you can do finder methods, find by name and address, even though there is no find by name and address method. But if the object has the proper properties, it can decide for itself that, yes, I can construct some clever answer from the question I just got, and can't even be checked in compile time.
So we already mentioned before that there is this feature of code blocks. So probably most people know the command pattern. from Java programming or something. So can you elaborate what a block is and also what closures are? And we talked about that before the recording here, and maybe elaborate on some of the differences or what you think the differences are and some of the conflicts or discussions around that. I think this is an interesting topic because most people probably don't know the difference. And if we don't know it either, no problem. But let's elaborate on that a little bit. What is a block? What is a closure?
A block in Ruby is just a block of code that it's dereferenced. It's not dereferenced, but you put it into curly braces or between do end. It's a block of code that you can send to other methods. Usually, when you call a library, some library method, it can take a block of code that it will execute. It's callback mechanism.
To illustrate that, if you have an array of elements and you want to multiply all the elements by 2, instead of writing an explicit loop and then doing the multiplication yourself, you just tell the array to iterate and pass in the behavior that it should kind of apply to all the elements. So you write a piece of code block that has that says multiply the argument to the block by 2, and then you tell the array to apply it to all of its elements. So you pass in a piece of behavior as an object itself, right?
Exactly. And if you look at Java, for instance, I think the most common example is comparison. When you do sorting and stuff like that, you have to pass in a little class instead of just a little method or a little code block that will say which object is larger than the other object from this specific perspective. A block is probably the only thing in Ruby that's not an object, except when you want it to be, because then it will turn into something that Ruby calls a proc. It binds to the local variables, and you can pass it around as an object. There's actually no difference from any other objects in that sense. And that was, to me, what closures were. Code block bound to local variables that you actually can pass around. But I got some really, really interesting questions on the tutorial. So I realized that I probably don't know. There's probably even more differences that's so far lost on me. But I'm going to find Eric Meyer later, and I'm going to ask him what the difference really is, because he said at the Speak at Yao that he really hopes that Ruby will get closures right in the next release. And I'm going to ask what he really meant.
Yeah, that's the discussions between language geeks. So, yeah. To get back to this bound to local variables, that means that if you define a block at some point and during the definition of this block you reference variables in the environment of that block, then if you pass the block around or make it into a proc object and execute it later, the environment is the environment of the time when you defined the block. So it kind of remembers the environment from the place of its definition, right? Because I think that is a very cool thing.
Precisely, and that's what the functional languages has done all the time, because that makes it rather easy to create a function that creates functions. You can create a function that has some variable points, and then you can pass in arguments to that function, and you'll get another function that has those variables, that remembers those, and really you create functions that create other functions. You write code that write code.
So as far as I remember, isn't that called currying or something?
Yeah, that's what they call currying in functional languages.
So that means if you have, for example, a function that takes 2 arguments, x and y, and for example takes x to the yth power, to the power of y is probably the correct term, then you can bind y, for example, to 2 and create a function that only takes 1 parameter, x, and basically takes it to the power of 2 and take that as a separate function. So you partially bind the values, right?
Yes, but yeah, that's exactly what they do, and it's I think it's a rather nice thing. And as far as I know, that's only possible in functional languages and some of the dynamic languages.
Yeah, I know it from Lisp, and I think it's possible in Smalltalk. No, I don't think. Anyway, I'm not an expert there. Okay, so that was blocks and closures. Does Ruby also have continuations?
Ruby doesn't have continuations right now, but if the rumors are correct, they will be completely removed in Ruby 2. They will just be gone.
So they're removing continuations. So maybe can you please briefly explain what a continuation is before we discuss about whether it's there or whether it's going to be removed?
Continuations is one of the things that I tend to think is the hardest thing to get my head around, because it's kind of like time machines, like having separate stacks and stuff, and you go back and forth in time. Jim Wyrick made a really, really nice illustration of continuations at RubyConf last year, where he used Zelda. When he used I don't know the character's name in Zelda, but he was 11 years old, and then he went to the Magic Stone and he turned 18, and then ran around, was 18 for a while, and then he came back, he did stuff, and then he came back and he was 11 again, and continued where he left off. So continuations is the only killer feature. There are not many uses that seem to be very widespread. It seems to be the continuations frameworks for web applications. Seaside is the only really well-used example I've ever heard of continuations.
Yeah, there's also Rife, I think, in the Java world, but it's still kind of a niche thing.
Yeah, that's true. This mechanism obviously makes a lot of trouble for language makers. So Mats just said, I'm going to take it out in Ruby 2 because it makes more stuff hard than the use actually is for it.
So I'm trying to give an example. I might be wrong here, and we might cut this out if I'm talking complete nonsense. If you have something that creates a sequence of numbers, okay, a sequence generator, then what you can do with continuations is you can basically implement the generator in a way that says basically a for loop counting from 1 to 5 million, and then you basically tell and the body of the for loop would be a statement that many people call yield, and that basically says return the current value, yield the current number of the iterator, like yield I if you iterate over the variable I. So you would yield I. That means somebody who calls this function give me the next value would get this return value, like 5 in the sequence, and then the continuation kind of remembers that it's currently at this place, so it's like a temporary return, and if you call this function again, it continues from there, counts one up, and returns the next value. So that's the kind of canonical example that I know for continuations. And yeah, it sounds like a nice feature, but it's not in many languages, as we all know.
No, I think you're right, but it's hard to think in temporal times in that way, and I think that's probably the main reason why it's not used that much.
Okay, let's get into more solid ground. Open classes, what is that?
Let's say you have a class. Let's say you would like to, for instance, in the Java world, you would like to add an aspect. You would like to add an after or before aspect. To do that, you have to use special tools that do bytecode weaving and stuff. If you would do that in a dynamic language, you will just open up the class. In Ruby, you just type class and the class name again, and then you will redefine the method. If you want to keep the old method, you just alias it and give it a new name that you hopefully remember then, and then write your new method that's gonna do stuff before or after, and then it may or may not call the old method depending on if it's guarding stuff or if it's just doing some logging stuff before. So you can open up classes, you can add stuff to it. You can add methods, you can remove methods, you can take out member variables. You can actually say in runtime that, I'd like to extend this class in runtime.
So if it implemented in Java without tools like AspectJ, what you'd do is probably you'd extend from the class and override the respective method, do some stuff, and then call a super method. But the difference is, of course, that this creates a new class, a different one. And if people want to use objects, they have to make sure they're actually instantiating this new type. So in Ruby, what you can then do is you can spread the definition of a class over several artifacts. So you can open up a class means you just add or remove to an existing class, right?
Yeah, exactly. That's exactly how it works. And since everything is interpreted, it's whenever it encounters this new definition, it will just start using it from that point.
So that also answers another question that I wanted to talk about, and that is the importance of aspect-oriented programming in dynamic languages. As some of you might know, the history of AspectJ and AOP is that it has historically come from meta-object protocols. So one could argue that aspect-oriented programming is kind of the stuff you've always done in dynamic languages hacked in a way so that it's applicable to static languages. So am I right in thinking that AOP isn't such a big buzzword in the dynamic language community?
Yes, you don't hear that discussion much at all. There's actually an aspect R, and it's a guy in Gothenburg whom I just met. He's actually been involved in that, so it's going to be really interesting to speak to him about this. But since you do most or even all of the tricks with standard language features, there's not much of a discussion actually.
So it's just part of the language and not a big deal. Another thing that I would guess is that testing is probably even more important than in static languages because the compiler doesn't do type checking, so you'd have to do a lot more testing. Is that correct?
No, since you're supposed to do that testing anyway. So you're not supposed to do more testing. You were supposed to do it anyway, because if you just think that the compiler will save you, then you will be in trouble anyway.
Okay, let's put it that way. You rely more on the fact that you have more tests because the compiler, I mean, there are obviously some errors the compiler catches. So it doesn't do that in dynamic languages. So test-driven development is okay, it's not more important, but it's critical that you have sufficient coverage.
Yeah, that's true. I'm just kidding. But still, yes, the tests help, but that takes... When I first started out with dynamic languages, when you started playing with JavaScript, I think the biggest pain was that since it was really hard to test, since it was in the browser, you had problems finding those stuff that the compiler actually helped you with. When I encountered Python and Ruby 4 or 5 years ago, then I was already test-driven, so I didn't have that problem anymore. The problem just went away, but it took a while before I realized that it went away because of the tests. Because the tests don't only check that I'm working with the correct types, it's also checking all the other stuff, of course, that are actually using the right values and things that the compiler can never ever do.
This brings us to the next point, which is, we named this episode basically in a way that suggests that we kind of want to convince static language users to at least take a serious look at dynamic languages. So what do you think is the best process, the best set of steps or whatever to go from static programming to dynamic programming? From what you just said, I take that it's a good idea to for example, get used to test-driven development because that's something that'll help you use dynamic languages. Are there other things that you'd recommend, like a team lead to do in order to convince a team that dynamic languages are great? So what's the process of going from static to dynamic?
I think first of all, like you said, tests are important, but also since with any new technology, you shouldn't just start doing a mission-critical project in this way. What we started out doing was creating tools, because you always have tools and you have your build chains that do this and that, and you usually do have to write some special code. And writing ant tasks in Java is actually not that fun. Try using stuff like JRuby and things like that to just try to sneak it in. If you want to try to do what I appreciate more and more is these small applications that normally took a couple of days to do. When you get a little bit fluent in dynamic languages, and if you find some frameworks that can help you, there are people starting discussing throwaway software. Software that you write that's you're gonna use for a week or so, and then you're gonna throw it away. And you usually do stuff like that by hand instead. You don't write a program to do it because the investment is too high. But let's say that the investment is much lower. Start out playing with dynamic languages to do stuff like that really can do small incremental stuff for you. And then when you get more confident, try to use. Let's say you're in .NET environment, play with IronPython. IronPython is .NET. IronPython works in .NET, and .NET is meant to be done with several languages. Use C# for some stuff. Use IronPython for other stuff. Use Visual Basic where it's the most elegant solution. Try to be more pragmatic and use more than one language instead of saying we are a Java shop, we are a .NET shop.
So how far along are those implementations of dynamic languages on the mainstream platforms, be it Java or .NET?
IronPython is released in at least version 1.0. I think there may even be an upgrade to that. And I mean, it's backed by Microsoft, and the creator works for Microsoft nowadays. He's also the same guy who wrote Python. JRuby is coming along. It's I think it's in version 0.8, 0.9, something like that. I think it's 0.9. And Sun just hired the two main developers. So JRuby has, compared to CRuby, some really interesting features, and it's that it actually uses Java's real threads, Java native threads, which makes threading in JRuby possibly even better than in CRuby, because that's one of the weakest spots. And still there are some features that are lacking that CRuby can do, but it's really coming close.
Just an editorial note, this session is recorded at Uppsala 2006 in October, end of October in 2006 in Portland, Oregon. So by the time you'll hear this on the podcast, a statement like Sun has just hired people might not be completely in time. So just as a remark. So if we look at JRuby, do you know whether it's actually an interpreter of Ruby implemented in Java? Or is it that Ruby is basically compiled down to bytecode? So is it a native implementation of Ruby on the VM, or is it just writing the interpreter in as it happens, Java?
As far as I've understood, it's a complete rewrite. It's rewritten from the ground up. There's nothing left.
So the point is that. Okay, so that means that you can probably use Java classes from within a Ruby program, a JRuby program, and the other way around.
Exactly, and they can speak to enterprise Java beans, and there are examples of calling all sorts of strange Java stuff, and I think they even got Ruby on Rails working on the JVM.
Okay, and I think the question I asked before about whether it's an interpreter in Java or whether it's using native Java features is probably I should have thought before I asked the question, because all those meta programming features, which we'll talk about in a subsequent episode with Obi Fernandez, you can't do that with Java. You can't at runtime modify classes easily. So that's probably the reason why it's, in quotes, just a Ruby interpreter written in Java running on the VM.
Yes, just.
Yeah, I said in quotes. So and on the .NET platform, I've always heard these talks about the .NET platform being better suited for implementing multiple languages compared to the JVM, because the JVM has always been or has been implemented with the idea of running Java, which is a statically typed object-oriented language. And rumors have it that the .NET VM CLR is implemented in a way that it, for example, supports functional languages natively. There is always this example that it supports tail recursion natively. So is IronPython implemented as a native CLR language, or is it a Python interpreter written in C# or whatever?
I have no clue at all, actually. Not at all. But the rumor, speaking of what you said, that the rumor is that the CLR is better, is, I don't know how true this is, but the creator of Python, when it was about to write a paper about how bad the CLR was for dynamic languages, but he thought that he should try first. So he started playing with it and realized that it was probably much better than the JVM. And now he's hired by Microsoft, and Sun is playing catch up and adding more and more stuff to the JVM to make it easier to do dynamic language.
So should people use JRuby or Groovy?
That depends a lot on what you want to do. The problem I have when coming to JRuby and Python and Jython and IronPython and stuff like that is that you have two libraries. You have the native the normal libraries for Python and Ruby, and then you encounter the .NET or the Java library, and it's like the old thing when you program C++ in Microsoft MFC environments and stuff. Should you use the Microsoft strings, or should you use should I use the standard C++ strings, and how do I do all the conversion stuff? You're back there again when you run a language on such a rich library.
So you're saying the real issue is today for people to learn platforms and frameworks and not languages. So the language is ultimately not that important.
I think languages are really, really important, actually. But the problem with switching languages is you have to rethink some concepts, and that's hard. That's the main aha things. But when you've done that, then you still have 6 months of learning libraries before you really feel that you are even close to productive. So that's a hurdle that I really would try to figure out a good way to get around.
Okay, so I think this wraps it up more or less. So anything else you want to say? Is like some pearls of wisdom that you'd like to leave with our listeners?
No, I'm sorry, I have no pearls of wisdom at all. But there are a lot of things in these languages that I like, and the metaprogramming stuff is really, really interesting, and I really look forward to listening to the podcast with Obi about the DSLs and the metaprogramming stuff, because I heard that he's done some really interesting DSL stuff. And I really hope people just, instead of being so afraid and saying that this seems dangerous, I think a lot of the discussion not a lot of discussion, but some of the comments that we had on the tutorial was specifically about the duck typing, that you don't know who you're calling, and how do you know that the ones that should respond to this message really can respond to this message. I feel that these are exactly the same arguments that we had for polymorphism 10-15 years ago. So let's just not keep repeating the same arguments every time we have a new cool technology. Just play with it and see if it's really, really that horrible.
Thanks, Niklas, for being on the show.
Thank you very much. It was fun.
Bye. Thanks for listening to Software Engineering Radio. If you want to get more information about Software Engineering Radio, or if you want to give us feedback, please go to our website at se-radio.net. You can also contact the team at team@se-radio.net, although we prefer entries in our comments system on the website so other people can see what you think. Software Engineering Radio wants to thank Henning Pauli for the intro and outro music, as well as Libsyn for providing the bandwidth. This episode of SE Radio, as well as all other episodes, is licensed under Creative Commons license. See the Software Engineering Radio website for details.